Hey everyone, we're here to start our first look at the final practice exam, the practice final. And we're going to look at questions 1 through 8 in this video. Question 1 is a pretty long one. It's multiple parts, so hopefully we'll get that out of the way. So we got the first part is to approximate the area between the x-axis and f of x from x equals 0 to x equals 4. A would be to use a right rectangle approximation. So my recommendation is always to organize your data in the chart. So the first line of the chart is always going to be, well, what is the interval? What are the intervals? That first interval is going to go from 0 to 1. Second interval from 0 to 2, 2 to 3, and then 3 to 4. After you have your intervals set up, we always put our delta x. So each one of these delta x's happen to be 1. Although they don't have to be 1, they happen to be 1 in this case. Now for the height, we're going to notice that we want a right rectangle approximation. So what we want to use then are the heights on the right side of the integral, or the right side of the interval. So in our first interval, the height at 1 is 4. So we'll put a 4 there. At our second interval, from 1 to 2, the height will be on the right side, which is 2, and the height at 2 is 8. The height at 3 is 5, and then the height at 4 is 3. So that's going to organize our data. We know that we have rectangles. So now we just need to add together all the delta x's multiplied by h for our height. So we have 1 multiplied by 4. We've got 1 multiplied by 8. We've got 1 multiplied by 5. And we have 1 multiplied by 3. When we add that together, we get 20. Question B is a left rectangle approximation of the exact same, of the exact same integral. So a lot of this is going to work out the same way. In fact, the first 2 lines of this are exactly the same, since the intervals, subintervals here, aren't going to change. We still have the same 4 subintervals. And the width of each subinterval is going to stay the same, since we are looking at the same subintervals. Now the thing that does change is we're looking at a left rectangle approximation. So we want to find the height on the left side of each one of these intervals. Looking up at my chart, we're going to use at 0, which is 1. We're going to use at 1, which is 4. 2 is 8, and 3 to 4 is 5. So 1, 4, 8, 5. We'll put together our integral exactly the same way. Here we have our first product is 1 multiplied by 1, and then 1 multiplied by 4, and then 1 multiplied by 8, and then 1 multiplied by 5. Multiply that together and you get yourself 18. Well, great. Well, that brings us to our next one, which is going to be using a midpoint approximation with only 2 subintervals. So let's go back up to the information, and if we're going to split from 0 to 4 into 2 subintervals, my first interval is going to be from 1 to 2, and then my second interval is going to be from 2 to 4. Remember that you're going to have to reuse that 2 because the end point of 1 is the beginning point of the next rectangle. So here we go, down at our chart again with our data, 0 to 2 and 2 to 4. The next thing to do is find the midpoint of each one of our rectangles. So we'll go back up to the chart, and if my first interval is from 0 to 1, the midpoint here is going to be 1. That has a height of 4. Back down to the chart, we're going to put a 4 here for the height. And actually, I forgot to put the width of each rectangle. So this one goes from 0 to 2. That's a width of 2. The second rectangle goes from 2 to 4. And that's a width of 2 as well. And now we're ready to look at the second rectangle, which goes from 2 to 4. We'll do something similar. 2 to 4 is this rectangle right here. the midpoint of this rectangle is 3, and that at 3 we have a height of 5. So coming back down to our chart, we'll put a 5 here. That should give us a good approximation. This time, my first rectangle has a width of 2 and a height of 4. That gives me a 2 plus 4, 2 times 4, plus, now my second rectangle over here is going to be, the width is 2, the height is 5, so we'll get a 2 times 5. So 2 times 4 plus 2 times 5, that gives me an 18 for that approximation. Notice how even though we're using less data, actually we're getting results that are similar to the right rectangle and the left rectangle. So even though we're using less, it doesn't mean that we're going to have anything less precise. So moving on to letter D, assuming that f is a velocity function, we're going to use our answer in part C to calculate an average velocity. So how do I calculate the average of anything in calculus? Well, if I want to find the average of f, I'm going to do 1 over b minus a multiplied by the integral from a to b of f of x. This is how we find the average of everything in calculus. Now, all we have to do is to substitute the things we know. In our case, our integral is going from 0 to 4, so we'll use 0 and 4 for our a and b. And the function that we want to average is f of x. Okay, well, next it says to use the answer in part C to calculate the average velocity. And what part of C? Well, we're going to use this integral from part C. So here we see that the integral is approximately equal to 18. So that's what we're going to put in there for the integral. So we get the integral is about 18. 1 over 4 minus 0 is 1/4. So the average, which was equal to that integral expression, is approximately equal to 1/4 of 18, which is 4.5. Next, letter E, where you're going to use a trapezoidal approximation for with 4 subintervals to approximate the integral. 4 subintervals, so the same subintervals, which means the same delta x's. Now, the thing that makes a trapezoidal approximation different is to get the height, we're actually going to average the two, the height on the left and the height on the right. So let's take a look at 0 to 1. 0 to 1, we have the height on the left is 1, and the height on the right is 4. So the average of 1 and 4, 1 plus 4 is 5. 5 divided by 2 is 2.5. Coming back down to our chart, we see that we have half of 1 plus 4, which is 2.5. Let's do the same thing from 1 to 2. From 1 to 2, we've got heights of 4 and 8. So we're going to do half of 4 plus 8, which is going to be 6. Coming back down, we've got half of 4 plus 8, which is indeed 6. Our next interval here is going to be from 2 to 3. Let's go back up to our chart and look from 2 to 3. So from 2 to 3, we have the interval is going to, the heights on the left and the right are 8 and 5. So we'll come back down to our chart and we'll use those numbers. So we got half of 8 plus 5. 8 and 5 are 13. Half of 13 is 6.5. And our last interval from 3 to 4. 3 to 4, we have a height on the left is 5 and the height on the right side is 3. So coming back down to our chart, we've got ourselves half of 5 plus 3, which is equal to 4. Now that we have our heights, which is really the average of the left height and the right height, we can go to our integral. So the integral from 0 to 4 of f of x dx, that's going to be 1 multiplied by 2.5 plus 1 multiplied by 6 plus 1 multiplied by 6.5 plus, and finally, 1 multiplied by 4, which is equal to 19. And if I'm looking at this, no, we're not quite finished yet with question 1. Question 1, part F, we're supposed to find the value of the integral of f prime of x dx, and then explain the meaning of f prime of x dx. So I already have pre-written here for you to remember the fundamental theorem. The integral from a to b of f prime of x is equal to f of a minus f of b. So let's tweak that to fit our situation. Our lower limit here is 0, and then our upper limit is going to be 4. Okay, so this means the integral from 0 to 4 of f prime of x dx is going to be f of 4 minus f of 0. And where would I get f of 4 and f of 0? Well, they're right here. F of 4 is 3, and f of 0 is 1. So coming back down, we get that the integral is equal to 3 minus 1, which is equal to 2. And if f is the velocity, this means that the velocity increased, or the value of f increases by 2. And that means the value of f is going to increase by 2 for x between 0 and 4. So f increases by 2 units from x equals 0 to x equals 4. Great, that was a nice long first question. Let's look at number 2 here. We've got the graph. This is going to be a long one also. So the areas of the shaded regions are 5, 4, 5, and 3 respectively. Let the antiderivative of f, let g be the antiderivative of f. And we know that g of 3 is equal to 7. And we're not going to go anywhere with this problem without talking about the fundamental theorem. So if we're saying that g is the antiderivative of f, that means that if I took the integral of f, I should get g of b minus g of a. So again, the integral of f is equal to g of b minus g of a. And this is true because g prime of x is equal to f of x, which is to say that g is the antiderivative of f. Okay, so now that we have that straightened away, we're going to find the antiderivative, or the integral from 0 to 2. And, well, the integral from 0 to 2 of f of x, we could say that's g of 2 minus g of 0, or we can use area to figure this out. In fact, that's what we're going to do for this first one. Area from 0 to 2 would be this right here. So that area, we're told, is C, and C has an area of 5. So the integral from 0 to 2 of f of x is going to be the area of C, which is 5. Incidentally, I want you to remember that you are looking at the graph of f, and f is matching the integrand here. So that's important for us to realize, is that we're finding the integral, or our graph is the same thing as what we're finding, or the function we're finding the integral for. So that brings us to letter B. Now we're going from -2 to 2. Again, this is the graph of f, so the integral of f is just going to be the area in the f graph between -2 and 2. Now, the difference in this one is that the area of B is going to, well, the area of b is a positive number, but the integral from -2 to 0, that's going to be a negative number. So the area is positive, but the integral is going to be negative if that area is below the x-axis. So the integral is going to be the negative of the area of b plus the area of c, which is -4 plus 5, or 4. So the integral here is going to be 4. Hang on, that's not right. Area of b is 4. So -4 plus 5, that's equal to 1. So the integral is going to be 1. Wow, can't believe that. Just lead me wrong like that. Let's take a look at question C. In question C, I notice that the integrand is in the wrong order. The larger number is on the top. Sorry, the larger number is on the bottom. And in order to correct that, or I can't find area unless I correct that. So in order to correct that, I'm going to use a negative sign. So we have the integral from 3 to 0 is the negative of the integral from 0 to 3. Let's find the integral from 0 to 3. So from 0 to 3, the area is the area of C plus the area of D. So we got the negative of the area of B plus the area of C, which is a negative of 5 plus 3, which is -8. All right, so finally, this gets us to question D, which is going to be the integral, or sorry, g of 0. And in order for us to get g of 0, we're going to have to, well, remember that fundamental theorem again. Except this time, we're going to take the integral of f, and the antiderivative of f is now g. And that sets us up nicely. Now, I see that we have g of 0 here is something we're supposed to find out. I've done these integrals a while, so I can probably be pretty well assured that we should make this upper limit 0. If you decided to make a 0, that's not going to be the end of the world. You can still figure this out nicely. Let's see, what should we use for a? Well, we were given that g of 3 is equal to 7. So if I put 3 here for a, that's going to work out actually kind of nice. All right, so we've got the integral from 0 to 3 is equal to g of 0 minus g of 3. Okay, that sounds great. Look, we actually already know the integral from 3 to 0. We know that the integral from 3 to 0 is equal to -8. So we can substitute -8 over here. So -8 is equal to g of 0 minus g of 3. Well, hold on. We're told that we know that g of 3 is equal to 7. So we can substitute 7 here for g of 3. All right, things are shaping up nicely. Let's add 7 to both sides. We'll add 7 to both sides. Then we'll do some arithmetic. And this gives us that g of 0 is going to be equal to -1. All right, last one here for question 2 is g of -3. We'll use our fundamental theorem of calculus again. I'll put that -3 over there for b, and just like before, I'll use my given information. I know that g of 3 is equal to 7, and we've built ourselves a nice equation based on the fundamental theorem. But, you know, I'm noticing that from 3 to -3, I haven't computed that yet, and that integral is in the wrong order. So if I want to use area to calculate the integral of f of x, I better put those in order. Okay, now that I've got those in order, I can use area on the left side of f of x to calculate this integral. Right over here, we're going to use area for this integral. So let's get back up to our graph. And this time we need to find the area from -3 to 3. So really it's this area, A, minus the area of B, plus the area of C, plus the area of D. So we're going to put all of those areas together, and that will give us the integral of f from -3 to 3. Let's go back down to our equation, and that's going to give us that the area of A plus the opposite of the area of B plus the area of C plus the area of D is going to equal g of 3 minus g of -3. Substituting values here, we get 5 plus 4 plus 5 minus 3 is equal to g of 3 minus g of -3. We know g of 3 is 7. This boils down to 9 minus 7 9 is equal to 7 minus g of -3, which means that g of 3 is equal to -2. Now, I think I said that we were going to go 1 through 8, but this video is about as long as I wanted it to go. So we're going to stop it here. This was questions 1 and 2, and we will see you here for the next one. Have a good one.